Okay, so we have been multiplying binomials for a while now. I've given you 4 examples here. You should be able to handle these very quickly. I want you to pause the video. I want you to multiply these 4 binomials, see what you get. Turn the video back on, check them, and we'll talk about them. So, check your work, and what I want you to pay attention to, I want you to pay attention to the numbers we started with and the numbers we ended with in the trinomial. So we started with 2 binomials, x plus 6, x plus 1. We ended with a trinomial, x squared plus 7x plus 6. Here's what I want you to notice. We had a 6 and a 1 in the binomials. The middle term is 6 plus 1. The last term is 6 times 1. Let's look at the next one. Does that work? We had y plus 3, y plus 4. The middle term is 3 plus 4, and the last term is 3 times 4. Same thing down here, c plus 2, c plus 6. The middle term, 8c, that is 2 plus 6. The last term, 2 times 6. And the last one, x plus 2, x plus 3. The middle term, 2 plus 3. The last term, 2 times 3. Okay, so as a reminder, to factor means to write as a product. So we're basically working backwards. They're going to give us the trinomial, and we have to find the 2 binomials that multiply to give that. What we have to remember is that that middle coefficient is a sum, and the last term, the constant, is a product. So we want 2 numbers whose sum is 6 and product is 8. We want 2 factors of 8 that add up to 6. Some of you, this is going to come very quickly. You're going to see this. You're not going to have any problems with this. You're going to be able to go through it in your head and get the 2 numbers that work. Some of you are going to need to make a list like I'm about to show, and that's okay. When you're comfortable with it, you can drop the list. So I look at 8. What kind of numbers multiply to get 8? Well, 1 and 8, does that add up to be 6? No. What's my other options? 2 times 4 is 8. Well, what's 2 plus 4? 2 plus 4 is 6. So that means on my 2 sets of parentheses, I'll have an x and an x because x times x is x squared. Everything's positive, so I'm going to have 2 positives in my parentheses, and I'm going to put a 2 in one and a 4 in the other. It won't matter which way here because multiplication's commutative, everything's positive, no big deal. You can check this. You can always check factoring by remultiplying. X times x is x squared. 4x plus 2x gives me 6x, and then 4 times 2 is 8. Okay, the next one, k squared plus 7k plus 12. Remember that the middle term is a sum, the last term is a product. So I want 2 numbers that add up to 7 but multiply to 12. If you need to make a list, start with a 12 and do factors of 12. 1 and 12, does that add up to 7? No. 2 and 6, that doesn't add up to 7. 3 and 4 do add up to 7. So that means in my 2 binomials, I'll have k and k, because k times k is k squared, and then I'm going to do plus 3 and plus 4. That should be a 4. So we can check it. K times k is k squared. 4k plus 3k is 7k. 3 times 4 is 12. If you want to, you can pause the video and try these 2 on your own. If you want to listen to 2 more examples, just keep watching. Okay, d squared plus 10d plus 24. Remember the middle term, the middle coefficient is a sum. The last term is a product. The constant is a product. So I need 2 numbers that multiply to be 24 and add to be 10. So I'm going to make a list with my 24. I'm looking for factors of 24 that add up to 10. 1 and 24, don't do it. 2 and 12, they don't add up to 10. 3 and 8, nope. 4 and 6, Ding, 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 ding. So my answer, d times d is d squared, and I'm going to have plus 4 and plus 6. I can check. D times d is d squared, 6d plus 4d is 10d, and 4 times 6 is 24. All right, last one. For our last one right here, x squared plus 11x plus 30. So I need factors of 30 that add up to 11. So I'm going to look at 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. 5 and 6 add up to 11. So my two binomials are going to be x and x. I'm going to put plus 5 plus 6. If I were to check that, I get x squared plus 11x plus 30. Here is a lovely little thing that can happen when you factor polynomials that you are not going to like. Let's say I'm looking at this, a squared plus 10a plus 30. And I say, okay, I need two numbers that multiply to be 30 and add to be 10. So I list all my factors of 30, which I think we did just a minute ago. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Did I miss any? I think that's all of them. None of those add up to 10. Not possible. Which means there is not a way to factor this. This is non-factorable. And when something is not factorable, you'll see this a couple of ways. You might have or might see it written not factorable, or they may call it prime. Like a prime number, like 7 can only be written as 1 times 7. You can't write it any other way. Same idea. So you could see both. You could say non-factorable, or you could say that this was prime. Sometimes you go through a lot of work to find out that a polynomial is prime, but it does happen.